date of the exam or later? About the date of the exam.
27.
We have
Finished.
We have another exam.
Next year we have wastewater. Yeah.
The same day.
We will talk about it, no problem. Matching, huh? You can take mine. I cannot sit in my office without this. Okay. So we are discussing uninterrupted flow facilities, which can be freeways or multi and highways. What we have done up till now is basically a summarized version of the analysis of basic freeways and multi and highways, which we covered in more details in the traffic course. Okay, so we talked about how to calculate level of service, number of lanes, the adjustment factors, okay, capacity and speed and so on and so forth. And now we are discussing the merge and diverge segments. They are part of the freeways. Merge and diverge are part of the freeways. Which part of the freeway? Which has a ramp. Okay, ramp is coming in, on ramp it's merge, off ramp it is diverge. For both these segments we follow the same methodology. The influence area of the ramp is up to a distance of 1,500 feet in the first two lanes of the freeway. First meaning immediate to the ramp. Okay, and what we have to do is find out the demand volume for the ramp and for the freeway, and then we have to find out how much volume we should expect in the first two lanes, the immediate two lanes. Okay, if you have only two lanes, then no problem, the entire volume of the freeway is in those two lanes. Okay, but if you have more than two lanes, then we have to look at some conditions. Okay, we want to find out the percentage of flow in the first two lanes. So if it is merge section, we call percentage of flow in the merge influence area. If it diverge, then percentage of flow in the diverge area. Okay, so these are the equations which will give you how much flow you should expect in the two lanes. And then we had these conditions, we discussed them. Let us look at an example to clarify this. Okay, we have an on ramp. Okay, so the ramp which is given with the arrow is the one which we are considering. You can see three ramps here, right? These are three ramps. Which one is our ramp? This one. Okay, now which ramp is this, on or off? On. Okay, it's going in, right? The one before this? On. The one after this? Off. Okay, clear? Okay, the distances are given. For each ramp the distances are given, and for each ramp the flow is given as well. Okay, the flow is given as well. Clear? Okay, and you get the data. Okay, now what we have to find out is the percentage of traffic which we can have in the first two lanes. Okay, in the first two lanes. It's not written here, but it's a 6-lane freeway. It's a 6-lane freeway. Okay, it's not written here. It's written both 6 lanes. Okay, good. Okay, I write it and I forget. Okay, and your problem is the other way around, right? You write and you never forget. And even if you have another exam, you write the same thing. Huh? Okay, 6 lanes. Okay, so each direction how many lanes? 3 lanes. Okay, what we have to find out is now this is merge, right? The first one is merge. So we have to find out the PFM factor, percentage of flow in the merge influence area. Okay, so I'll be looking at this one. First of all, I don't have 4 lanes, it cannot be. I don't have 8 lanes, so this is not my case. Clear? Okay, moving on. I have 6 lanes, right? 6 lanes, I could be here, here, or here. Okay? My PFM could be this value, or this value. Okay? Depending upon what? You have to look at this table now. Okay? Which equation to use out of these 3? It will come from this table. Okay? Now in this table, my ramp is on. Okay? Do I have ramp before? Yes. Do I have ramp after? Yes. So I have to look for a case which had ramps on both sides. This is before, this is after. Okay? Now the before ramp was on, right? Before ramp was on. Which one has on? This one, this one, this one. I have 3 cases with on ramps before. Okay? Now what was my after ramp? Off. Okay? So out of these 3, which one has off ramp after? Only this one. Okay? Now this one says what? You can use equation 5.28. Okay? And 5.28. No, sorry. 5.28 or 5.30. I can use the first one or the last one. Okay? So this one is out. The middle one is out. This one or this one. Okay? Depending upon what? Depending upon D and LEQ. Okay? D and LEQ. What is D? D is my distance between the 2 ramps. Okay? D is my distance between the 2 ramps. Okay? So for the on ramp it is 1200 feet, for the off ramp it is 1000 feet. Okay? On ramp 1200, off ramp?
Which one? Which distance you take?
I'll come to it. Clear? Okay. Now I'm comparing D with LEQ, right? What is LEQ? LEQ is the distance up to which the ramp can affect the other ramp. Okay? LEQ is the distance up to which one ramp can affect the other ramp. Okay? So if the distance between the 2 ramps is equal to LEQ or less than LEQ, then one ramp affects the other. If it is more, then the 2 ramps are not affected by each other. Okay? For example, let's say your LEQ is 2000 feet. Your LEQ is 2000 feet. Okay? If the other ramp, the next ramp or the previous ramp, is within 2000 feet, then the flow of that ramp is affecting your ramp as well. Okay? If the other ramp is more than 2000 feet away, that means that flow has no effect on your segment. Clear? Clear? Okay. Now I am comparing D with LEQ, right? I have to compare D is more than LEQ or less than LEQ, right? Okay. So D and LEQ should be for the same ramps. I cannot take D distance for the off ramp and take LEQ for the on ramp. I cannot do that, right? They should be for the same ramp. Okay. LEQ is only given for upstream off ramp or downstream off ramp. Both of them, which ramps? Off ramp. So D should be for the off. Clear? Okay. So this answers your question. Now, going back to the question, which ramp is off ramp? The other one. What is the D for that ramp? 1000 feet. 1000 feet. Okay. So if LEQ is more than 1000 feet, I will use one equation. Less than 1000 feet, I will use another equation. Okay. So now give me the value of LEQ. What do we need? Which case do I have? Was it upstream or downstream? Downstream. After. Okay. So I'm looking for this equation. Okay. What do I need? What is it? Los Angeles, right? Acceleration length. Okay. The extra length which you give here. This is acceleration length. Okay, so the length of this lane, acceleration lane. Okay, what is VD? Flow of the downstream ramp. Flow of the downstream ramp. This is VD. So this is 400. Okay, VD is 400 and LA is 400 feet. Yes. LA is 400. This is a mistake. Let's cross it out. LA is 400 feet. Acceleration lane is 400 feet. Clear? Okay. VD is 400. LA is also 400. Okay. Give me LEQ. Hmm? Give me 1 second, 1 second, 1 second. VF is 2000. VR, which is the flow on your ramp, how much? How much is that? Huh? 200 on the middle ramp. Okay. VD is 400 and LA, yeah, LA is also 400. Okay. So then how much is LEQ? Okay, so VD, VF, VR, these values are given. Okay, VD, the flow on the downstream ramp. Okay, because we are only taking downstream. Sorry. What is this? One second. Sorry. Use this one. You have to use this one. Sorry. This is for the diverge case. We are doing merge, right? Use this one. Use this equation. You need the same things. Okay, so VD means the flow on the downstream. LA is the acceleration lane, which is 400 feet. Okay, you only need these two things here. Why I selected this? Because I have a merge segment. My ramp is coming in. I have an off ramp downstream after. Okay. So how much is LEQ?
2624.
2624. Okay. This is length. Okay. Very good. Okay. Now the condition changes if it is more than D or less than D. Okay. My D is 1000 feet. For the downstream off ramp, this is 1000 feet. Okay. So LEQ is more. Okay. D is less. Actual distance is less. The required length is more. Okay. What does it mean? This ramp will have an effect on my ramp. The flow of this ramp will have an effect on my ramp. This is what it means. Okay. Anyways, so we are looking for the condition here. We were here. On ramp upstream, my ramp is on, and off ramp downstream. I have to select between one of these conditions. Okay. My D is less or more. D is 1000 feet and your LEQ is 2000 something. Okay, so D is less. So that means what? I will use equation 5.3. Clear? Okay, so what is my PFM factor here? VD is again 400. Okay, and this is distance, length to the downstream ramp, which is 1000 feet. Okay. This is saying what? That 65% of traffic will be in the first two lanes. The third lane will have 35% traffic. Okay? Clear? Any questions? You have question? Why did you? Okay, look at the second case. It's an off ramp now, so diverge. It's an off ramp, diverge. We are again looking at the middle one. Okay. The flow on the freeway 2200. Distance upstream ramp 800. Downstream ramp 1500. The flow upstream 500. My ramp 1000. After 800. Okay. This is an off ramp, so I will not have acceleration lane. I will have deceleration lane. Okay. This one. Okay, for going out. So deceleration lane. Okay, but the length of deceleration lane is still 400 feet. Okay. I'm looking for this factor now, PFD factor. I don't have 4 lanes, I don't have 8 lanes, so these two cases are out. I have 6 lanes. Okay. 6 lanes, I have 3 options. For 6 lanes, I have these 3 options. Okay. Again, I will go to this table to find out which option is suitable. Okay. Now my lane is off. Okay. The one before it is what? On. And the one after is this? Off. Okay. So on is this one and this one. Only 2 cases have on ramps before. Okay. And one of them should have off ramp after. So only this one. Okay. In this one, I can use this equation, or this equation. Are there any conditions given? No. So all these 3 equations are acceptable. All these 3 equations are acceptable. Yes. You have to look at what type of ramps you have. My ramp is off. Before it, on. After it, off. So my ramp is off. Before it, on. After it, off. So this one, this one, this one. Clear? No conditions here. No conditions right now. Okay? So obviously all 3 of them cannot give you the same answer, right? They will give you 3 different answers. So which one? Eventually you have to select one, right? Maximum. Okay? Maximum will give you the worst case, right? But here, if somebody says I will not take maximum, I will take the middle one or the lowest one, acceptable.
Which one will give us the maximum? There is
I don't
one
know.
equation will give us the maximum.
I don't know. I've not tried. I don't know.
One equation will give us the maximum in every case.
Yeah. But is it always the same equation giving the maximum? I don't know. Okay, maybe in one case this equation will give you maximum, in another case this equation will give you maximum. I don't know. Maybe. Okay. Because it depends upon volume, right? So volume keeps on changing, so any equation give you maximum. Okay, clear? Any questions? Okay. So in this case, we can use any of these equations. Okay. So for example, if you use the first one, then I need the freeway flow, and I need the flow on my ramp. Okay. How much flow is on the freeway? 2200, right? Okay. And how much is on the ramp? 1000. Give me the PFD for this case. Okay. For the next case, again VF is 2200. VU is the flow on the upstream ramp. and the LF is the length to that ramp. Okay, so VU will be 500 and LU is the distance to this ramp, which is 800. Okay, so VU is 500, L up is 800, VF is 2200. How much is this now? Huh? 1? Everybody, huh? Okay. Okay, for this one, we need the freeway, and then we need the V down and L down. Okay, meaning the flow on the down ramp and the distance to that ramp. So V down is 800, and the distance to this ramp is 1500. Okay, 800 and 1500. How much is that? I'm using this one. The VF is 2200, 800 and 1500. Okay, so you can see this one and this one are very close, and this one is the worst case where we are saying the third lane will be empty. Okay.
Second one is like more than one. Okay.
You cannot take it more than one, right? PFM, PFD, these are proportions. Okay, so if it is 1 point anything is 1. Okay, clear?
So we'll take one.
Yeah, 1. Yeah. And the equation should give you, should not be like this is in the 4th or the 5th decimal place, right? It can happen, yes. But it cannot be like you are getting 1.5 and 2 and okay. That means there's a mistake. Okay, because if you see in the equation, all factors are in decimals. Okay, so it should not give you so far from 1. Clear? Okay. So you will find out PFM or PFD. Okay, for merge segment we need PFM, for diverge segment we need PFD. Then you will put it in one of these equations and find out what? The flow in the first 2 lanes. Okay, either for the merge or for the diverge. After PFM and PFD, the next thing you find out is V12. Merge or diverge, whatever case you have. Clear? Okay, so now I know the value of flow in the first 2 lanes. Now you see this value. This value, okay, it's 1. That means what? The third lane is empty. Does it make sense? We have 3 lanes. We have ramp after ramp, and nobody is going in the third lane, away from the ramp. Nobody is going away from the ramp. Does it make sense? It does, right? Okay. So we need to make a check. We need to make a check for V12 values. So remember, you found PFM or PFD. You put it in those equations. Now you know according to these factors how much volume we are expecting in the first 2 lanes. Okay, but that volume should make sense. Okay, so they have given us 2 checks here for that volume. The volume which you have calculated for the first 2 lanes. The first check is that the per lane volume of the outer lane. Okay, for the outer lane. Let me give an example. Let's say you calculate the total flow was 4,000. Let's say 4,000. Okay, you calculated V12 to be 3,000. 3,000. Okay, so 3,000 is in the first 2 lanes. How much in the outer lane? 1,000. Clear? Okay, so outer lane has 1,000. Now we can have 1 outer lane, or we can have 2 outer lanes. If there are 4 lanes, then 2 lanes are inner, 2 are outer. If there are 3, then 2 are inner, 1 is outer. We're asking his permission. Okay. So if it is 1000 and we have one outer lane, how much per lane? You're looking at my finger, huh? Okay. 1000 outer lane, 1000 volume in the outer lane. Okay, total was 4000. Okay, 3000 in the inner lanes, two inner lanes, 1000 left, right? So that 1000 in the outer lane. Okay, if there's only one outer lane, per lane is how much? 1000, right? Outer lane total is 1000 and there we have only one outer lane, so per lane volume is how much? 1000. If there are two outer lanes, not maybe 500, come on. Okay, it is 500 per lane, right? Okay, now what does the check say? This per lane value should not exceed 2200 or 2700. This per lane value. Okay, not the total, the per lane of outer lanes, the per lane of the outer lanes. So you calculate the number for the first two lanes, see how much is for the outer lanes and divide by the number of outer lanes, which could be 1 or 2. Okay, clear? Let's say your total was 5000. The first two lanes have, no, let's say the total was 6000. Total is 6000. The first two lanes have 3000. Okay, total is 6. The first two lanes have 3000. Okay, if there is one outer lane, total is 3 lanes, one outer lane. Okay, so per lane volume for the outer lane is 3000. Does not satisfy the check, right? Okay, if there are two outer lanes, per lane will be 1500, which is good. Clear? Clear? Okay. Go back to the first case. The first case was 3000 in the outer lane, which doesn't make sense. Okay, 3000 in the outer lane doesn't make sense. So what do? Then we will adjust the V12 by this ratio. Okay. So you have already had a value of V12, right? You will discard that value and find it out from here. Okay. So your value was 3000. Total was 6000. You calculate V12, 3000. Huh? No, VF minus 1. Okay. So total was 6000. You calculate V12, 3000. But when you do 3000 for V12, your outer lane is 3000 per lane, which is not good. Okay. So now we come here, you recalculate V12. So VF is 6000 total minus 2700. How much? 3300. So V12 will be 3300. Clear? Okay. If the same thing happened for two outer lanes, so total is how many lanes? Two outer, two inner, total 4 in one direction, right? So it's an 8-lane freeway then. Okay. If you exceed the ratio in 8-lane freeway, then your V12 will be this value. Got it? Okay. Clear?
Doctor, for 6, 2 inner and 4 outer. Yeah.
6-lane freeway. So every direction has 3 lanes. So 1 outer. Clear? Okay. Clear or not? So first of all, you find out V12. Okay. Then subtract the V12 from the total. You will get the volume for outer lanes. Divide by number of lanes. You will find it per lane. If that per lane is more than 2700, then use this one or this one for V12. Clear? Okay. Any question? Clear or not? Okay. This is one check. Okay. Another check is on the ratio. Okay. Again, per lane outer volume. Per lane, like we did in the first case. Per lane, right? We were doing per lane, right? Per lane outer volume should be less than or equal to per lane of the inner lanes. Okay. Let me again go back to the example. Okay. Total is, let's say VF is 6,000. Okay. First two lanes 3,000. Okay. How much per lane? How much per lane?
3,000.
Why 3,000? How many lanes?
The 6 lanes.
How many lanes? Is this one?
2 lanes.
Two lanes. These are always two lanes. These are always two lanes because this is for the two immediate lanes. It cannot be one or two. This is always two. Okay. So per lane how much? 1,500. Okay. Now remaining how much? Total was 6. V1, 2, 3. How much remaining? 3,000. Okay. So if I have 6-lane freeway, so every direction has 3 lanes, 2 inner, 1 outer. So per lane for outer is how much? 3,000. Okay. Now they are saying the outer per lane of outer should be less than or equal to 1.5 times this value. So how much is 1.5 times this value?
2250.
This should be 1.5 V12 per lane. Okay. So what is V 1.5 of this?
2250.
2250. So we have a problem now. Okay. It should be less, right? But when I do 1.5 into this becomes less. Okay. The outer one is higher. Okay. So check not satisfied. Check is not satisfied. If it is not satisfied, then you will use either V again. Where we are making the change? Always. We are making the change in V1. Okay. Here see V1. Whenever we don't satisfy the check, we will change what? We will change V1. Okay. So now whatever value of V12 was what? 3,000, right? You cross it. Now your new V12 will be total upon 1.75. Okay, got it? Clear? Okay. You have two checks. Outer per lane should be less than this value. If not, change V12 by this or this. Okay. Second check is outer per lane should be less than or equal to 1.5 inner per lane. Okay. If it is not, V12 is this one or this one. This one for 6 lane, this one for 8 lane. Again, 6 lane meaning 3 in each direction. Okay, and 4 meaning 4 in each, 8 meaning 4 in each direction. How many outer lanes here? 1. How many outer lanes here? 2. Clear? Okay. So this is all done to find out what? Okay.
So let's say we can do only one or we have to do both?
Both. We have to do both. Okay. If you did one and it is satisfied, the other one is not satisfied, you will change it. Okay. If you did one and that one was not satisfied and you change the value, like we did here, If you apply this here, this check will not satisfy, your V12 will change. If I put the same values into this check, my V12 will change. Okay, so I will have a new value of V12. Okay, then for this check I will use a new one. You will not use the original one. So you applied this check, not satisfied, you already changed V12. So when you come to this check, use this value. Clear? If you use this value, most probably it will satisfy. Most probably it will satisfy, because both of them are following the same approach, that your outer lane volume should not be very, very high. Okay? They are both checking for the same thing. Okay? So if you applied one check, you satisfied, you go to the next one with the original value. If you applied one check, not satisfied, you change the value, then you go to the other check with the new value. Clear? Okay, but both of them should be applied. Okay. Yeah. Okay. Then the next thing you should find out if your demand is more than capacity or not. If your demand is more than capacity, what is the level of service? This is the question. F, right? So my analysis will stop. I don't need to do anything more. If I come to this point, I found demand is more than capacity, stop, done. Okay, level of service F. Easy, right?
Easy for example.
It doesn't come in the exam. Okay, maybe. Once one student complained to me that you gave the same question in the exam and we didn't prepare for it because that already came. So we thought you will give us new question. Huh? 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 Forgot. Maybe him, maybe him. All of you have taken traffic with me, right? Maybe one of you, I don't know. You check yourself. Hey, he doesn't. Maybe him. Maybe. I don't remember. He will not do it. Okay. Pay attention here. Now, we have to check capacity for three things. Capacity of the ramp. Okay. If there is a queue on the ramp, it will affect the freeway, right? So level of service will be F. Okay. So check the demand. Now you know the flow rate of the ramp. Check if the flow rate exceeds the capacity of the ramp. What is the capacity of the ramp? These values. Okay. So take the value from here and check it with the flow rate of the ramp. If the flow rate is higher, capacity is less, level of service is F. Okay, analysis finished. Next one is capacity of the freeway. Capacity of the freeway. Okay, so again, find out the, now you have the flow of the freeway, right? Okay, compare the flow of the freeway with the capacity of the freeway. Now there's a problem. What's the problem? It is per lane, right? Okay, so what do? Which value should I check with? Total, per lane, inner, outer?
Berlin.
Huh?
Outer. Maybe Berlin outer.
Per lane, outer? Always? Which one should I check with? It could be per lane, outer. But always? Huh? How do I decide? I have a per lane for inner, I have a per lane for outer. Which value should I select? Huh? Which value should I compare with? So the capacity is, let's say, 2250. Okay. Per lane outer, 2400. Per lane inner, 2000. So outer has a problem, inner has no problem. What should I say? Level of service? F or not? Should be F, right? You cannot say this lane has F, so I will discard it and just focus on the remaining ramps or the remaining lanes. It cannot happen, okay? Okay, so this value whatever value you are getting from here, it should be checked with both. If you exceed in any lane, inner lane or the outer lane, you have a problem. Level of service F. Done. Okay. So if the flow of the ramp is more than its capacity, level of service F. If the flow per lane for the inner lane or for the outer lane is more than the capacity, level of service F. Okay. Now here I don't have a problem because they give me a range of free flow speed, right? Okay. So for the entire range, this is the value. Here there is no range. More than equal to 70, this value. But what about 78? Huh? What about 78? Oh, sorry, not 78, 68.
Turbulation.
Huh?
Turbulation.
There's an equation. So go back to the equation. There's an equation to calculate capacity using free flow speed. And even in the equation, you just put free flow speed. Okay? But the value is not here, you go back to the equation. Okay? Anyways. Yeah. So, capacity of the ramp, check. Capacity of the freeway, check. Then, the capacity of the merge area. Capacity of the merge area. Merge area includes what? Ramp and the two inner lanes. Ramp and two inner lanes. Now, this is not per lane. This one is not per lane, total. Total. Okay. So capacity, and this is for the diverge area again, total. Okay. So this will be only V12 and this will be V12 and ramp both. Okay. If the total exceeds this value, then level of service F. Clear? Okay. If you exceed the value from any of these tables, the level of service is F. Okay. In this case, if you exceed here, okay, they are saying yes, it could be F, but we still continue. In these two cases, we will stop the analysis. In this case, they are saying okay, even if you are above this value, continue. Okay, because if one lane is blocked, then basically the drivers will go here and there. Okay, so they are saying okay, we can still continue. This is what I said. Yeah. Level of service, if you want to know the level of service, you must know density. Okay, this is the density values for merge and diverge area. So the table is slightly different. The value of density is different. Okay, for a basic freeway, level of service A is up to 11. Density of 11. Here it is up to 10. Okay, so it's not the same table. But for merge and diverge both, it is same. Okay. Then now how to find out the density? For density, if you have a merge area, you will use this equation. If you have a diverge area, we will use this equation. Now what are we using here? What is VR? For the ramp. Huh? Yeah. What is V12? The first two lanes. What is LA? Acceleration. Yes, yes. Yes. Okay, for diverge area, V12 same. What is LD? Deceleration. Okay, clear? Okay. Then this table gives you the value of speed in the merge or the diverge area. Now you see here we are calculating density without speed. Okay, but speed is also important for the freeways. So we can find out the speed using one of these equations. Okay. If you have merge, you will use this. If you have diverge, you will use this. Okay. This one for ramp influence area. This one outer lane. Ramp influence area means how many lanes? 2. So in the first 2 lanes, speed equals to this, where ms is from here. In the outer lane, speed equals to this. Okay. But then you have to also look at, so speed can be equal to this, this, or this, depending upon the per lane volume in the outer lane, not the per lane, total. VOA means total volume in the outer lane, so it's not per lane, total. Okay. So if the total volume is less than 500, this is the speed. If it is between 500 and 2300, this is the speed. If it is more than 2300, this is the speed, and so on and so forth. So this is for merge and this one is for diverge. Okay, again for the first two lanes and the outer lane. Okay, and for the outer lane again we have to decide on the basis of the total volume in the outer lane. Okay, yeah.
So the OA what?
The total volume in the outer lanes. Okay. Okay, clear? Okay. Now we did what? We found the speed of the first two lanes and we found the speed of the outer lane. Different, right? Okay, these are two different values. Now, how to find out the average speed? So these equations give you the average speed for the whole segment, inner plus outer. Okay, average speed for the merge segment, average speed for the diverge segment. This is average. Okay, so previous table was giving you a speed for each lane different. This one is the average of all lanes. Clear? Okay, and we are using the same values. Okay, BR12 means total ramp plus first two lanes, DOA outer lane, NO number of outer lanes. NO is number of outer lanes. SR is speed in the influence area, SO is speed in the outer lane. B12 flow in the first two lanes, BOA flow in the outer lane, number of lanes outer, and so on. Okay? Clear? Okay. We will not do the example, but just have a look. Okay. Which ramp we have? On ramp. Okay. So which area? Which area? Which type of segment? Merge. Okay. We have merge. Okay. What do we call this? LA, acceleration. Okay. This is free flow speed of the ramp. What is CF and SF? Adjustment factors. Okay. So they are saying one, meaning no adjustment. Okay. Peak factor is given, type of terrain is given, 5% flux and so on and so forth. Okay. This is volume from the ramp. Okay. How many lanes we have? 4 lanes. Okay. Free flow speed of the freeway. This is for the freeway. Okay. This is for the ramp. Okay. What is the first thing we will do? Free flow speed is given. Okay. If it was not given, this will be our first step. Free flow speed was not given, this will be our first step. Next step. What is the next step? Capacity? Before. Before. We did the same thing. The second step is the same what we did for the freeway case. Basic freeway and multi-lane highways. You were saying something? No. Before that. Flow rates. Okay. These values are volumes and they are in vehicles per hour, all of them. You have to convert it to passenger cars per hour and into flow rate. Okay. So you will divide it by FHV and peak hour factor. So the first thing you will find out is the FHV. Okay. Rolling terrain, percentage of trucks are given. You will find out FHV. Okay. Then this value divided by peak hour factor and FHV will convert it to flow rate in passenger cars per hour. Same thing here. Clear? Okay. Then we will start with B12 and PFM and so on and so forth. Clear? Okay. So bring the flow rates tomorrow for the freeway and for the ramp. Okay. We will find out FHV, then each value divided by peak hour factor and FHV. Okay. We will proceed with the rest of the steps tomorrow. Clear? Okay. Exactly. Huh?
About the exam.
Yes, about the exam. Cancel the exam, right? Final out of 80.